Well, hello everyone, it's Nano here again, and welcome to the live stream. So this is currently the machine learning series, as you can see here, but this is in general just the Nono.ma live channel where I do creative coding, I do machine learning, and I do things that have to do with design and the creative process. The first thing I'll ask, as always, is if you can hear me okay. Put a thumbs up or say yes on the chat or something so we know that audio is coming through, and then we're ready to get started. Okay, so what are we gonna see today, right? We're still going through the machine learning series. This is live number 11. We haven't missed 1 week yet, and I hope we don't have to in the near future, even though we might have to during the holiday. I will remind you, as always, I know I always say this, but it's really helpful to like the video if you enjoy this content and this is a type of videos that you would like to see more of. If you're learning machine learning or if you're liking these things, just click ahead and like the video. And subscribe. Subscribing is useful if you want to get notified when I upload new videos or when I go live. And if you click that bell, you'll get notified on top of being subscribed to the channel. We have a Discord community. There's a few people there who are already starting to collaborate and participate on the project. So I invite you as well to be part of this. And yeah, you can go to nono.ma/discord and then you'll get the instructions to join our server. And if you already have a Discord account, it will be really easy. Otherwise, you'll have to create one. As always, we covered some things that have to do with machine learning in this case last week. That was live number 10. The video is up on YouTube. Their channel, their chapters, so you can go through those and skip ahead to the sections that you're more interested of. And in last one, specifically, we covered trying to understand a bit more what Teachable Machine is doing for us and using data augmentation techniques that the new or latest Keras API offers that you can use in TensorFlow. So in summary, creating a sequential model that we could use to pass images through, and those images would come out with slight alterations in like degrees of rotation, or you could add things like scaling, zooming, contrast, and other operations. So yeah, you can go back to last week's if you want to get going with that. Another thing I'll mention, so I have this guy here that has been around my hometown during the last week. We had the chance to catch up, and we recorded a new episode of the podcast that I hope I'll be releasing really soon, hopefully in the coming weeks before the month ends. Otherwise, we'll have it in January. As you can see, the shirt says Parametric Camp. That's his channel. If you don't know about it, it's a channel where he's covering a lot of things that have to do with coding, mainly algorithmically for coding geometry, and also visual programming with Grasshopper. He also has an entire course in C# programming and computational design, and a lot more. So I invite you to go. This is Jose Luis Garcia del Castillo, for those of you who don't know about it. He's been on the podcast before. So yeah, keep an eye on that and you'll see the episode be released soon. All right, so embroidery. So this is something I've been learning about lately. So this is, embroidery is just like using those sewing, right, with thread. But lately I've had the chance to use or to make use, not myself yet, I'm trying to learn, of machines that do this automatically. My partner has a machine, and we're learning how to use PEmbroider. That is a library from Golan Levin and other collaborators that you can generate embroidery files from processing. And these are some tests that I have been doing there, just trying to generate weird paths with which you can sew or embroider your clothing. So this is one example, and then croquetilla. So this is another example, another illustration that we have been testing. Yeah, so with this you can customize your clothing, your textiles, and your maybe shirts or other things. here's another video. This is just an outline. And yeah, and this is just an image of those things. All right, so this I showed because we might be seeing some of that code in the future. I don't really know if that's of interest to people, so just let me know if this is of interest, but I'm definitely a maker and I want to keep learning about this, and I'll be showing more stuff in the near future. All right, and as always, today I tried to keep it short. Let's start coding. We promised that we were going to look at some web interface building and also native, or not native, but desktop application building with Electron, React, and TypeScript. So today the entire day is for this purpose, I think. I don't know if we're going to take a look at other things, but let's get started. All right, so let me see. We have a set of nodes here that we have been taking a look at for the past weeks. So this document that I'm trying to put together with all the nodes that I use for the live stream. And today we're up to live 11, as I mentioned before. There are many things here that I'm not going to be able to cover today, but that we will be taking a look at in the future. Today probably we're just gonna have time for this. I can see on the channel a question about the name of the library, so let me actually bring that up here. So I have this browser. Yeah, so the URL, I probably should have put that and give credit on the notes on the slides, but I forgot. I didn't have the time. So this is PEmbroider by Creative Inquiry. I want to thank everyone who contributed to this. It seems like it's these 4 amazing people so far that we have here. And you know what they've built is a library that is open source and allows you to do a lot of stuff, even customize patterns and build your own vector fields in a way that you can fill in shapes and stuff, and then generate paths that will work with your design, so you can embroider your clothing or textiles, as I mentioned before. Okay, so let me just take a look here so you can get a grasp of some of the examples on the cheat sheet. So, you know, cheat sheet shows you pieces of code of the things that you can do. Let me move myself to the other side of the screen so you don't see me in the middle of the code. Yeah, and I want to say hi to everyone who's connected so far. So I see Pedro and Sajay and Bea on the channel again. So thanks for being there. And yeah, so this is PEmbroider. This is the library I'm using to do those embroiders. As you can see, there is like compatibility or like this is a processing library. If I open processing here, we're gonna see an example. And the other thing I wanted to show is their example. So there is a really illustrative list of example files that they ship with the library with the code to produce all of these things, which I think it's amazing. So they have many possibilities. Some of the things I was trying look a bit like this circle, like this one, and I have a lot of stuff to test so far. But what I really like is that they have custom, already made tools to create paths. So this is embroidering paths from vector information, such as loading SVG drawings and loading them in different ways. So maybe the outlines or infills and stuff. And also, like you can see here, so we're inputting this is a PNG, I think, so black and white map. And it detects that all the white things probably are vectorized or something. And then they have different patterns to infill these graphics. And it's pretty powerful. And then the last part of the story is that they also give you this application that they say is great for kids, so no coding required, and it's fairly limited to what you can do, but you can generate embroidery paths with your mouse just clicking as a drawing app. So it's like a paint app to develop embroidering files. All right, so let's see if I have quick access to recent files. Well, there are some here that are from the examples, so I don't think I have anything of the files I showed before. Let's see what runs in here. All right, yeah, so this is, I would say, it's really cool, but it's a bit boring because it's none of the files that I showed before. Still, you can get a hint on what this is here. So this, if I zoom in even a little bit more, those pink points are the points where the machine will, the needle will enter the textile and make like a point on a path on the drawing, right? So you can get an idea, like here in this one, for instance, you'll get like a pattern like like really dense, while some others will be a lot less dense, like this one. So yeah, this is PEmbroider. I would like to see more of it in the future. If you're interested, let me know. We can take a look at that. All right, so getting back at here, I've been promising that we're gonna take a look at this for weeks now. So this is using trained models on the web. What does this mean? So we have a good example here. If I open, what's going on here? All right, so if I open this one here, oh no, my webcam went out again. I love this. I don't know why they do this. All right, so this is a website that is under URL as we saw last week, right? So we can start here in some way. So we have this model that has been exported to TensorFlow.js format. I'm not sure if we're gonna be able to see the model here. Yeah, they probably do some magic behind the scenes to load the model from here. But the gist of this is that this is a website. It's hosting a model that is built with JavaScript, and we can use the model in the browser. So we could get to some, load an image, and then it will, in this case, classify it in black and white or a color drawing, right? That's what we saw last time. So let me see if I can get my, and hello Lourdes, thanks for connecting. And we have here, let me just see if I can make myself appear once again. Right, I'm back. Okay, so let's see what we can do. Let me just actually try to do something that you might be able to also do in your computer. So TensorFlow Hub, I think it was TensorFlow Hub, the one that we looked at a while ago, that we could see, if you remember, we could go here, we can look for different models that are online already trained, so pre-trained models or like already trained models, and we could define the type of model we want. So in this case, we're going to go for TF.js to be able to use the models on the browser. And what we'll do is that we're going to just download one of those models. So today we're not going to see anything that has to do with training. We're just going to try to get a model that already exists and load it in a website tab, like a web browser. Yeah, and hello Major, thanks for connecting, glad to see you around. All right, what model might we use from here? Let's look at the problem domain. And let's just go for image classification. That seems to be the most straightforward so far. So, okay, so we have here, let's just get maybe ResNet and try to do with that one. What I want to show is like, we don't really need to care that much about what model we choose just yet. We just need to know how to do it. And then later we can worry about maybe getting our own model and using it in a way. If you go to previous live streams, I think live stream 9 or live stream 10, yeah, probably live stream 8, I don't know, the one that was on Thanksgiving Day, I think we saw how to use a model that we've trained in a Jupyter notebook. So we trained a model or downloaded a ResNet model or we used a Keras.applications model that was a ResNet one, and we run inferences with it. We're going to do something similar, but in JavaScript, in a way that can run in your browser directly. All right, so 9.2 million downloads. That's a number there. And you have the URL, so we could post the URL here, and this gets served. I don't know if you would be able to use that from there to load it directly. Version 3. Let me see. All right, load graph model. This model can be loaded using TensorFlow.js as load graph model. All right, so nice thing that we can do already. So it seems to be there is a one-liner that we can use for this. And okay, let me come back here and pause for a second. So the live stream is telling me that there is not enough video to maintain the streaming smooth. So I would really appreciate if you can go to the chat and just write if you can hear me fine, if if you can see me fine, and if the thing is lagging, if it's going slow or if it's going well. Just put thumbs up or say it's fine or whatever you want. All right, let's go back. So I was here. So load graph model. It seems to be a one-liner. What I want to really do is we want to download the model, host it ourselves, and be able to load it from there. But for now, we're just going to stick with this one so we know how to load the model and how we can run that. Another thing we can do to simplify things is that we can use Glitch. So we can use glitch.com. I have an account there already. So this is a platform where you can code and look for code examples and just build web applications in a testing environment that you don't really need to set up your own server or create do a lot of the infrastructure setup that usually takes a lot of time and energy when you just want to test things. So let's go to search, and I'm gonna search for TensorFlow.js. I don't know, a genial project that does faithful things. Google's TensorFlow.js teams enable machine learning in JavaScript. Yeah, that means we work right. We work, I think 3 times. Let me see. And I just want to see projects. Hello world for TensorFlow.js. Absolute minimum needed to import. Okay. Well, I mean, the first thing that I'm daunted by is that this is a huge resource here. So these are a bunch of examples that have to do just with TensorFlow.js that I didn't expect to find here. So I was just meaning to build one of these, but it seems there are many. I'm going to zoom in here so you can see some of them a bit better. And we can see here there's like TensorFlow.js plotting, modal hosting, MNIST fork, making predictions from 2D data, a demo, MNIST, simple linear regression, postnet, body segmentation, the iris classification, object detection. So there's a lot of things. Yeah, so Major, I will take a look at load graph model in a second. It's just a method to load the model. Okay, so let's take a look at this thing. So what I want to do, all right, that wasn't intended. So there's some sound on that video. Wasn't intended to sound there. All right, so and that reminds me of one thing I need to take care of here. All right, cool. Let's see. TensorFlow.js. Let's just start with the minimal example. If you're not familiar with Glitch is a platform you can sign up. So I have my own account here, and maybe we need to first see what Glitch is so you can understand what we're doing here. Otherwise, it's going to be a bit confusing. So hello web page. Let's just create this. And Glitch, as I said, we're going to create a new project. There are many ways that you can create a website. If we go here into the terminal, we could go to my desktop, make a new folder, and just create. So let's see, we have the web folder, and I'm just going to make an index.html file. So for those of you who don't know what this is, so you can create the base of an HTML website with this boilerplate code that I have here, and I could save, and then if I open, that opens here, it's an empty website, right? So what I'm doing here is editing an index.html file, and if I just put some text here, let's say I put a title and a paragraph, so I'm just coding this from scratch. This is my paragraph. All right, so we open the website again, right? So this is my website. It's not anything fancy, but we've just done that. And if I press on Mac, Command Alt U, you can see the source code of that. So you see that this is the source code that I just wrote. And you know, right now here we're just using HTML. We could also use something like JavaScript there. So if you click on inspect and get to the console here on Google Chrome, I can write things here that are JavaScript. So this is JavaScript for those of you who don't know. So I've defined the name variable as nono, and we have that running there. The same way I can do that, I can go into the index.html file, and I could write a script tag and then say, okay, now console log, this is, or like JavaScript script says hello. Right. So now when I load this page again, so I reload, you see that this message pops up on the console, right? So we've executed HTML, and HTML has loaded this script, that is JavaScript code, and this code has executed on the website. You can either do that inside of script tags, or you can run something like this. So you're referencing an HTTP URL or HTTPS with the source code of that JavaScript file. So if we click on here, now you can see this is the source code of jQuery, not minified, by the way, which is not good practice. And much of those codes is usually stored on CDNs. So CDNs, if I look for CDN jQuery min, for instance, I can see this library minified and compressed or minified. So if we go to jQuery 3 minified, you can see that in this URL we'll have the code in a way that is unreadable, but is lighter for the browser to load. All right, so why am I explaining this? I'm explaining this because if you look for CDN TensorFlow.js, there's also, and I don't know where we're gonna get the, yeah, so probably here. this is the HTML tag or script tag. Let me just put this above so I don't cover it with my head. This is a script tag. This is all we need to put on a website, on an HTML file, for the browser tab to download the JavaScript code for TensorFlow.js and have our browser loaded. And we can just go here and go back to our index file, and I'm gonna put this here. So I'm gonna remove the jQuery tag, and I'm going to, well, yeah, so we're gonna remove that, and we're gonna save. For those of you who are not familiar with the console, maybe I just can open this on Visual Studio Code. I'm not doing anything weird there. I'm just editing a text file. So this is our text file. All this boilerplate you don't need to care about. This is just like things that I have here that are defaults that you might want to add there, and some of it might be a bit old. So we have here this script code that loads TensorFlow on our browser. And if we go back to our tab, so in here, we don't really see anything, right? You're loading this thing here. And let's go back to that tab. So you don't see anything, but if you go here to network, and I'm sorry if I'm explaining this too slowly, but for some people who might not know anything about JavaScript and the web and stuff, this is background knowledge that you might be able to use some other places or to follow along with what we're doing in a way that makes more sense. I just want to explain right now what Glitch is giving you for free. All right, so what we have here is that if I reload my tab, you can see that there's these resources. There's and I'm gonna move this that way so you can see the waterfall. There's this waterfall here that corresponds to the different files, right? So bootstrap.css, which I don't really need to have here, it's being loaded. I can refresh so we don't load that. It was, Bootstrap was loading a lot of crap, like all these things here that we don't really need now. So what we're loading right now is just this index.html file. That is the one that we've written, is on my machine. And then over the internet, we're loading tf.min.js. That is this file that shows up in there. That is in jsdeliver.net. That's a CDN. That's a content distribution network that hosts TensorFlow.js, in this case, version 2.0.0, in a minified way. So if we go in there, we won't be able to read the code, but we can preview it. So licensed by Google, and there is a lot of code here that we don't really care about right now. That's the code of TensorFlow.js. So TensorFlow.js is being loaded here. What can we do with it right now? Let's take a look. So there is another way you can use TensorFlow with npm, so that's with Node. We can maybe see how to do that later, but you just run npm install or yarn install, or yarn add TensorFlow TF.js. And yeah, so sample code, right? And this is a snippet of how you would use it there. So you can start with TF, so you define a sequential model, as we were doing the other days, and then you can do operations. But for now, we're not gonna do npm. Node.js, all right. And yeah, so here, this is what we wanna see. So we have the script tag, that is what we're using at the moment. And we're going to take a look at how to use this code. So it's a similar example to the one in npm. So right now, what I'm gonna do, I'm just gonna put my code in the right and my browser on the left, and then my browser on the right. Let's actually swap and make it the other way around. All right, I'm here and my website is here, and now I want my code there and my website here. All right, that's really sad. So I can simply add here a style to make all the fonts that we display be inter, that I very much like. So at least we have something that looks a bit nicer. All right, we're loading TensorFlow JS. So let's get more room here. And we have many tabs here we don't really care about. Oops. Okay, my tab is here. All right, I see a question on the chat here. So, is CDM script stored locally? If a function is called in TensorFlow.js or jQuery, is it searched locally or on web for different functions? All right, so when you have on the cloud, so you have a function or a JavaScript file, so the .js is as when you have an image on the cloud. When you have it on HTML, you're making a request. So if I, for instance, put here an image and say, okay, that's going to be none.ma, image u. Let's see what face can we get here. Jambasova masked PNG. I hope I'm getting this right. And we'll make the size of width 300 pixels, so this doesn't go over. Not working. Why not? That. Okay. So let's try. Let me just take a look at something. Well, when things don't work, just go here. So, okay, yeah, my bad. All right, so I just need to put this here. All right, so here we're loading. Just make sure that exists. Yeah, so this is a URL of an image, right? It's an image on my server at none.ma. And the image is on the cloud. When the browser executes and it creates this tag, what it does is that it makes a request to the server, and that PNG image is downloaded into the browser, so into my machine, cached, and then it's rendered on the browser. So the image is on the server, but I download it, so you're displaying it from data that is on your computer. And that's easily something that we can see if we get to here. So if we get and we go to, I think, network. So if I refresh now, just normal refresh, you can see that these items here, so where it says Tatiana and TensorFlow min, they've been loaded from the disk cache. That means that they weren't downloaded again, but they were just loaded from my computer. So if I refresh with Command-Shift-R, you can see what happens here. So these files, that's nice. So you actually see how much time the file takes to download, right? So it's downloading there. I'm refreshing constantly. So we're downloading the file from the internet. In the case of the image, we're downloading pixel information and displaying it. In the case of the JavaScript file, we're downloading a bunch of JavaScript code. So downloading that file, just the text. And then the browser is executing the text, and then TensorFlow is live on your tab. So on your browser, that code has been executed. So the TF variable that we're going to use now, the TensorFlow.js library, is present on your tab, right? That's the same way that if I were to do this, so if I am to do something like constant none equals, and then I can define something like this. So I define the function that is going to get, for instance, two numbers, so A and B, and it's going to, so maybe you just put something that makes more sense, so A plus B, right? So we're defining that function, and then anywhere we were to use that function in the browser, so we can add 3 and 9, and then you can see that it returns 12. So the code, once downloaded and executed on the browser, lives on the browser tab. To the question, the script is stored locally and the function is executed locally. I don't know if that answers the question, but hopefully it does. Okay, so let's keep going. Let's leave the console here. So we're saying that we are loading two things. We're loading this image, and we're also loading, So let's see again, we're loading the image and we're loading TensorFlow.js. So now in our console, hopefully this works. I can write TF. TF is what, here in TensorFlow in the example, this is what they're using. So they're using TF.sequential and these brackets to define a model for linear regression in this case. So what I can do is I can go back here and just do TF. So if I do add and then press enter, well, I refreshed, so my function is not defined anymore, but I can run it again. And if I now press just run and then click, you can see it just tells me, okay, this is a function, gets A and B parameters, and it returns A plus B, right? So that's the summary of this. Yeah, and I'm glad that if that answers your question. All right, so now what I want you to see is that if I do TF and then press enter, we get returned that object that is actually a model or a set of functions that is TensorFlow.js that has been defined when we download, and then that gets executed in our browser. So if we go here and comment out the image, comment out that script, when we reload, there's no image and there is no TF, right? It doesn't exist. We could do TF equals function that returns no TensorFlow.js, right? So now when I call TF, it returns that function. But if we uncomment those again, so we're having the image and TensorFlow.js, and we can inspect all the things that TensorFlow.js has for us or has to offer by doing TF and then pressing enter. So we can see all the operations that we can do, all the functions, all the properties, right? They're all here. And this is another way to learn the API of different libraries. You can do this with jQuery and with any other thing. All right. I hope this was useful. So you can also do things like, oh, we have the version variable, TF.js, right? So in an application, we could do things like this. We can do TF version, TF.js, right? And we could say, is this equal to 2.0, 2.0? True. If it's equal to 1.0, false. So we could, we could use things inside of the library itself for our code to inform the scripts we do and how we do it or how it executes. All right, let's get started. So we have now here a console where things like the sequential function to define a model are available. So we can define a model and now we have this thing that is a model. So it has functions like, I don't know, I haven't really looked at it a lot, but it has function layers. It has the function, probably has the function add. Let me see. So if we take a look here at my tabs, I had this open here that what they do is model.add, TF layers, blah, blah, blah. All right, so we've defined the model. Hopefully we can do something like that, right? We can do model add and then add this, right? Cannot read property length. This is a smart trick, I don't know. Yeah, so this is how JavaScript works, right? So you're defining things on the web tab, and you could run many of these things if I were to do something like this. So I click Node, and here we have a REPL. So this is a console, this is a REPL that you can do similar things. So you can define the add function here in one line, and we return A plus B, and then I have my add function, and oh, A is not defined. Yeah, all right, so I made it wrong. So constant add 2, we need to put here A and B, return A plus B, and now we can use that function. All right, 7, let me just, I don't know if you can see that, but we've done, we just define the function this way, and we cannot define it again because we defined it as a constant. All right, what I wanted to show is that the same way we did that with, let me move myself again here. So the same way that we did that with Node, and we can do that on the REPL, we can do with Python. So we have this Python REPL, so everything that you can see there are things that define that the Anaconda Python version has started. So we have those those 3 lines that we can see here. And those 3 lines mean that we can execute Python code. So we can do things like this. And we can also define functions. So we could define a function here and then do operations. We could define my variable here and have that there, right? So it's like a persistent environment or program where things that you define are there. So I can say, okay, what's name? But then if I exit and then enter again, that name doesn't exist anymore, right? So that's the same as when you open a browser tab, there is a session, things that you define there are there until you close the tab. All right, let's keep going. What I wanted to show is that, you know, you can run this TensorFlow environment in many different places. So the TensorFlow.js environment you can run in JavaScript, on the browser, on Node, and some other places, right? Let's go back to our tab. So I have TensorFlow. We were looking at the things that we can do with TensorFlow. And what we can do is that we can type here. So I said like, oh, constant model equals TensorFlow sequential. And I define, all right. So we reload, we define that, and then we have our model. We could do add, we could create TensorFlow layers, input, right? Or like convolution to the, you know, we can do these sort of things, right? And we're gonna do this right now. Well, but right, like even though we can do it here, what we can also do is that we can leave our tab in here. So we could leave this thing here to be logging things, right? So when we load, we see this message. And let me just put that bigger so you can see it. We don't have too much space here. And then the other thing we can do is that we can write that code in here on any of these script HTML tags, right? So this is an HTML tag that is a script, and anything we put there gets executed. There is another story that the order in which these things get executed is sort of intuitive, but it's really not, because it goes linearly, but then things that are inside of the body can be deferred to be executed later, or, you know, there's like ways where you can make sure that the website loads in the most friendly way for users. All right, so let me go back to the left, and now what we have here, let me just see what you guys are saying. All right. Okay, so what I was saying is that the code that we were executing here, we can put here as a one-off. So this console log JavaScript script says hello, that runs once. When, you know, the HTML file executes, boop, 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 and then when it goes here, it executes and it prints there, and then it continues and shows the website. We could do that here. So we could say hello console, right? And then that prints here. But that doesn't make that much sense. You won't console logs when things happen on your website. So let's actually try to console log TF, right? So one thing I can do is like if I have a name here, I define or a model, I can do this. I can do console log model, and then the console is going to log that. Right now it doesn't make sense because we can directly write the model name here and get that there. But if we were to define something inside of our HTML file, so let's say my name is Nono, you could log the name here, right? Right, so name is here. And another thing we can do, you'll notice I use these 3 syntaxes interchangeably. There are some differences between them. These two are more or less the same. This is a bit more strict, but then this one is, I think, is more modern. Inside of this one you can use variables with a syntax that I very much like because it simplifies code. So instead of, for example, you have name here. So instead of doing this, that is what you would commonly do, you would do something before like this, JavaScript and so we can say JavaScript. Imagine I can say JavaScript and no, but using the variable, the name variable. So I would say here JavaScript and then close this. So this is a string plus, I want to put here the name variable and then plus and then another string, right? So we're going to see if that works. So that works here, JavaScript and no say hello, but we can do the very same thing if we just do this. If we put like the $sign and then the variable inside there, and then, you know, we get this working and you get that populated there. All right. Yeah, this is sort of a crash course on front end because we want to see some of the, you know, if we're going to use JavaScript with TensorFlow, you first need to know a bit what JavaScript really is for the web. And I think this does it. I don't mind if we don't have time to cover a lot more today than just running a bit of TensorFlow.js. You know, we might have to do more sessions. I don't think we have time 1 day a week in 2 hours to do too much stuff. But let's get going and see more stuff. All right, so we're defining a variable, we're logging things to the console, and I'm gonna do something that is not gonna work, but you know, we can do console log TF. And I think, well, let me see. Yeah, this probably is not gonna work. I would bet that this will fail. So I refresh and it says TF is not defined, right? Why is that? Because if I go here, last time I checked, if I click on TF, that exists. So why is that? I let you to guess, but we're gonna see it in a second. So I mentioned before there is an order in which the browser loads your things. So there are two ways to do this. One way is to move our script tag to below the tag that loads TensorFlow.js. So after this line, you know, here, no TF defined, but here, TF has been loaded, thus defined, right? So if we put the tag here, that's one practice, we can do that and then it works. So it's actually printing this line. We can verify that by just copying this a couple times. So that's getting printed. But another thing that you can do, and this is what I mentioned before, is that I think you can put this on the header tag. So you can actually put it here and then use the modern feature that you can say here, defer, right? So this defer tag, what it's gonna do, I hope, is, well, this is actually wrong. So it's going to wait until the end to load. And yeah, that gives us an error. I don't know if you can defer this JavaScript code to execute afterwards. Let's just try it. So even if I put it above, and this silly thing, it shouldn't. All right, so that doesn't work. So that defer is when you want to defer the loading of a JavaScript script that is on the cloud after other things on the web and the HTML has been loaded. All right, so we're gonna leave it like this, not like that. We're gonna leave it like this. And we're gonna remove the defer. So first we load TensorFlow.js, here load TensorFlow.js, and then here we define our custom code. All right, so now that works. After this lengthy explanation, that works. We have TensorFlow, and now what I want to say is we can work with TensorFlow here. So define our TensorFlow model. All right, so all this explanation was just to get here, that now we have a tab, we have an HTML file, we have a browser tab that is loading TensorFlow, and we can write TensorFlow.js code here. Is that cool? I think that's cool. All right, so constant model tf.sequential and then semicolon. So we come here, there's nothing. I can do model that we've defined, and we have our model. All right, great. Let's see. So we have a sample code here that we're going to, yeah, let's say, yeah, we can use this code. So as always, I like to rewrite the code and not just copy it so we can understand it. But what is going on here is that we are defining a model just with one layer. We're compiling the model, specifying what loss it needs every epoch to be able to optimize the model in the right way. The optimizer is SGD. I think it's a stochastic gradient descent. The loss is mean squared error. We have synthetic data here. That I'm not sure what this syntax stands for. And then we feed the model. And what's really cool is that with JavaScript, we can, as we feed the model, we have this syntax here. We feed the model input, output, parameters, so how many epochs. Then, so we have a callback here, so this seems to be promises. So we have a callback function. Every single epoch, we're going to predict with the model on the sample data and then print the results. Okay, let's write the code. I mean, you have it here, but I'm going to leave it there if you want to write it with me. I don't know if you're following, but I will just be writing. All right. All right, so is there a sequential model? Let's just try to see TF sequential TensorFlow.js. I would like to see if there's, if we can use the array syntax that you use to define the models with normal TensorFlow, and that might be the Keras API. All right, so we have here TensorFlow sequential, add. All right, yes. Awesome. Yeah, I mean, let's just try to make it a bit different so we don't just copy and paste the code and have the same thing. So there is this syntax, that is the one that I like. It might be a bit confusing here in JavaScript, but you can specify a set of parameters, you can specify the layers inside of that object, and you can pass an array of layers that we're gonna use on our model. All right, so let's just copy that syntax and we just adapt a bit this script for ourselves. So we add an object here. So we have our sequential object and we put an array that I'm going to put this way, and then we will put here our layers, and we'll be able to add many, right? In this case, if we go to our setup function, we just had one. So we just had this dense layer that has units equal 1, and input shape is, what is it, 1. Super complex model. And if we go here, that's our layer, and I think that's it, right? So we're defining this sequential model by specifying an array of layers. The alternative syntax is what you can see here. So you do model add, and you will have one model add line per layer you want to add to your model. Nice thing here that I like is that you can do this thing. You can just add many layers this way to your model, right? But for now, we're just gonna delete them. All right. Let's see if this compiles, if this works. All right, no errors. That means that our model is working, so we can do model layers. And we have one layer. It's a float. It's a dense layer. So yeah, this seems to be working. let me see. Let's change the person. So if you actually build this URL with people from the podcast, I have all the images there. So Cristobal Valenzuela, a bit more related to AI and machine learning. Oh, maybe Chris. Maybe not. Not all of them are there yet. Right, Adam Menges. Okay, so we are here and we now have to compile our model. Compile, and what we saw that we had to do is put our optimizer and our loss function. So we just put our loss and our optimizer, so stochastic gradient descent and mean square error. Squared, important, squared. All right, model, does it compile? We reload here, model seems to compile. It's good to go checking step by step, otherwise you're gonna have to debug to see what's wrong later. I'm gonna read here. So Pedro says that he didn't know that there was this way of formatting in JavaScript. I thought it was possible only in C# and Python. Yeah, it seems like many languages implement features like this one because it's, you know, it's more fluid to write code this way than just having to concatenate strings and doing this thing. Or, you know, as an IC of things that I didn't really do this that much before, but a way to format, if we had like name and maybe, oh, I'm writing JavaScript in Python. So if in Python you have like name, nono, and place, Spain, you can format directly like this. So you can do my name is, and I live in, right? So you now format and say name and place, and then boom, right? And that actually does the same way of formatting, right? And if you want to see something, and this is, you know, this is an abstract or like something that doesn't have to do anything with what we're doing today, and that's me. So I can define a set of, for instance, parameters, or let's just call it params, and I can say nono, Spain, snake, and microphone, right? So I just have an array of things, and I can also format it like this. Name is, place is, animal is, item is, right? So you do that, and if you do this, it will fail, right? But you can add, so this is just putting an array here, but if you add the asterisk, that works. Isn't that awesome? I discovered this recently. I don't know what it does, don't ask me. It just, I think it explodes the array into a series of parameters, and can use the letter F at the beginning and forget format method. Can you share an example of that, Pedro? I have seen the F command, but I think I know what you mean. So just doing something like this. Is it like this? Okay, yeah. That's right. I didn't really, well, that's cool. I like that too. I don't know why I've been using the format one again. Okay, I'm also learning. That's cool. If you have any other tips on how to format your strings in any language, just put them on the chat, put it on the comment. I would love to learn more about it. Yeah, thanks, Pedro. Thanks, Pedro. Cool. All right, so let's get back. We have this and we're almost there. So we're gonna define our inputs and outputs. So these are input data and output data that we want on the model. And what we're gonna do is constant x Let me see how I can do this so we can see the code. All right. Maybe this way. Oops. All right. So input TF tensor to the 1, 2, 3, 4, 4, 1. Yes, TF tensor to the 1, 3. I like to write these things from scratch. So from scratch, I mean copying the code even if I'm typing, because that way it helps me memorize, right? All right, so train the model using the data. We get model fit, we do XS, YS, and epochs we're gonna set just two to test, and then we can do this, but we don't really need to. Let me just write here, training the model. We don't really need to put a callback. We're gonna add it, but I just want to see that this executes. Yeah, my bad. Training the model, yeah, and then maybe we can put here done. Right, it's really fast. It doesn't really take time. If we put here 200, same. I mean, this model is too small, so yeah, it doesn't really care. All right, 200,000 iterations takes a bit of time. All right, let's leave it at 2. And now what we want to do is we're going to add a callback here. So we have the code here, just adding a callback to predict. But before adding the callback, let's actually just predict. So let me zoom in here a bit more. Let's actually just do model predict and then print. So what we can see here is that you can pass a new tensor. So this is your tensor input data. So we can do here predict with TF tensor to the 5, 1, 1, and we print it, right? So this is our output, is minus 363. Every time it's different. I'm not sure what this is doing. All right, let's actually put this thing inside of the training loop. So we just put here this function called the model predict, and we have to, yeah, we don't really have to do anything. All right. And let's see if there's something that is not working here. Print. Okay. What does print mean? So print might be in a different place. Let me see. Epoch. Huh. Maybe let's put here 10 epochs. This doesn't seem like it's actually training. Then not sure. Not really sure what's going on right now. So if I fit compile, let me just try one thing. Let me just try to copy and paste to see if I have any errors. Okay, yeah, so it seems like it was working. So let's go back to our code. So what's going on is, let me just put this a bit smaller in here. It's training for 10 epochs, and then it's predicting. The thing is, it's not doing what I thought it was going to be doing, that was logging for every epoch. So on epoch and callback TensorFlow.js. And I'm not forgetting, I still have the tab here for TF load graph model. Okay, so I know there is that question. We looked at this at the beginning, and we're gonna use that right now. All right, so let's just get to this. Let's see if there's writing your own callbacks. TensorFlow, TensorFlow 2.4. Sorry for the distraction, but this seems like TensorFlow versions. Nice. Okay, 3 days ago. I didn't really know that TensorFlow 2.4, 2.0 was out. So that's good news. All right, just put that here. Yeah, so Mayur, that's what I'm gonna try to do right now. So we're going to try to run a loop per epoch and do something. All right, so I have this here. Great. Let's see. Keras callback, no, TF.js callbacks, fit. Document fit callbacks. Add stop training models. All right, callbacks. Is this JavaScript? Yeah, callbacks. Awesome. So on batch end, on epoch end, we want on epoch end. So this is something that is nice. We're gonna add it to our code. It's not there on the example that we saw before, which is good. So I'm gonna go here and define a function, what we want to happen when each epoch ends. So let me know if you can see the code right. I keep making it bigger and smaller. So on epoch end, and this naming is completely optional. What we're gonna do is define a function. So we were looking at this code right now, batch logs, whatever. All right, so maybe we can get the epoch and the logs and just log epoch accuracy logs, make it smaller, logs dot accuracy. I don't really know. Okay, it seems like it's a shortened version. And now what we're gonna do is here we gotta probably just in this object. So maybe we extract this thing, config. We can get this a bit better. So callbacks. Do we pass an array? On epoch end. And then here we put our config. All right, who bets this is gonna work? Hopefully. All right, nice. Awesome. Accuracy is not defined. We don't have that metric in our model, but it works. All right, let's see what metrics. I don't know if you understand what's going on. So I define this on epoch end function, which gets epoch and logs. We don't really know what's in logs in this callback. And it seems like there are a fixed set of callback functions that you can call inside of in the fit method, right? In the callback. So it can notify you on the start and end of epoch or batch. In our case, we're notified at the end of every batch using the callbacks, and other options include on train begin, on train end, on epoch begin, on epoch end, on batch begin. and on batch end, right? So let's see the documentation of feed. So we have these arguments, we have callbacks, which, you know, it's defined here, or are defined here. And yeah, we could have them report on every different operation, and they're all their nice things here. We're not going to take a look at right now. All right, so let's try to do something here. So I was trying to print the logs. So here I'm going to print the logs because it seems like log.accuracy doesn't exist. So we're going to do this again. All right, so loss. Well, yeah, we only have our loss. I don't know if we can get our metrics to accuracy, and I don't really know metrics. Yeah, okay. Mean absolute error. Epoch end. And this doesn't say what the logs contain, right? The logs, the content of the logs is something we can look at other day, but it might depend on the definition of the model or what the model is. All right, well, we have that, so we're gonna get just what we have. So loss. All right, so we can do loss. We know that our loss needs to be going down, and yeah, the loss seems to be going down. This is pretty cool. I mean, I'm happy that we're training a model here, even though we don't fully, I mean, this is a linear model. I don't fully understand at the moment everything that's going on, but this is just a linear model. We're trying to fit the model, and we're going to train for, let's say, 30 epochs. All right. Okay, so we get the loss to 30. Let's actually train for 100 epochs. Let's see what happens. Boom, our loss keeps going down. And when we try to predict on this data, 511, I don't really know how this data is being is being formatted. So the shape is 4-1, so it's just a linear. Okay, so this is the shape of the tensor, and it's just like a 2D. How is it 2D? It's just like a one-liner, 2 dimensions. All right, I don't. Is it 4 components of 1, right? So we have like a vector, a vertical tensor. One thing I find frustrating with new TensorFlow version is old TensorFlow version code is not compatible with newer version. All right, I think they're trying to fix that. So TensorFlow 1.0 or 1.15 or something, when they switched to 2.0, there were a lot of breaking changes, but they're just trying to update the language to make it a lot more, a lot better, like improving it in many different ways so it's easier to work with data. All right, so what I imagine that what this is just a vertical, matrix or tensor. So it's like 1, 2, 3, 4, and this is mapping to a number series, right? So if we look at plotting this, can we plot this? Plot linear model online. All right, so 1 to 1, 1 to 1, 2 to 3, 3 to 5, 4 to 7. Label, what's the label? Oh, x, ys. All right, so our linear model, let's save this image here. All right, let's open it big. Okay. And let me go to the right. So this linear model here, right? It's easy. So we have the coordinates of 4 points. So 1 and 1, 2 and 3, 3 and 5, 4 and 7, right? So 5, if we were to calculate that properly, we could calculate linearly that the 5 would have to go. So we're getting, this is a, I cannot think right now, but this is 3. So 1, 3, so we're growing 2, and if we get for 5, we'll just get 9, right? So in this linear model, I'm a bit slow right now. I'm really tired today. All right, so we have this thing. I don't know why I have to keep writing this over and over and over. And this. So what we're trying to do is that we had more numbers, right? We know that this linear model has to work something like this. I think so. I don't really know. Maybe, yeah. So it's a linear model, right? So we're calculating that function just by giving it examples. So we're giving it 4 points, but we want it to be able to plot more points. Right now, what's happening is that the loss is going down, but it's still not getting close to 0. And we can get here, right? Like we get the prediction for number 5, and we get 8.34, while we were saying that it should really be for 5, it should be 9, right? So it's getting closer. So one thing we can do is that at every single epoch that we train, we could print the result. So we could put that in here. So we predict every single epoch, right? So we can see, if you see here, the result that we're getting at the beginning with, just the first epoch is 1.75, which is like the model doesn't know anything. And then, the number keeps going up. So it keeps going up towards converging towards 9, right? Which is nice. So right now we're not going to do that. Well, actually, yeah, let's leave it there so we see when we converge into the result we want. So for this model, we're going to train for, let's say, 300 epochs. So we put it here, and then we see how this is going. Let me move again there. All right, so we're getting there, but still not getting close enough. Let's just try to increase it a lot more. 1000. Let's see when we get to that. It seems like it's learning. It's like a simple model, and the loss keeps going down and down and down. All right, we're getting there. All right, still not perfect, but it seems like we have a model. So we can do here model predict, and we can do a TF tensor 2D. We can pass number 7, and hello. All right, so I see Jose Luis is here. Let's bring back the slide. I don't know if you were here before, but yeah, and Mayur, thanks for being there. I'll see you next time. All right, so let's go to that slide for Jose Luis that he just connected. I hope that he can stay for 1 more minute or a second. I'm just passing through these things. All right. yeah, so Jose Luis is online. So this is the guy I told you about. You should check out his channel, and we're gonna have an episode really, really soon. And yeah, so I just wanted to show this again because I put you in there today. All right, let's get back to TensorFlow.js. So we're trying to build a classifier. Let's for context. Let me just let me just see if I can bring this guy. Is this guy here? No. All right, so we're gonna hide the image for now to give a bit of context and put here training a linear. So this is it's a linear regressor in TensorFlow.js. All right, so okay, so we have what we're doing at the moment is we are trying to see when this converges, right? So what I was doing at the moment is that if I just passed a 1x1 shaped tensor in 2 dimensions, we're getting, let me just do print. Okay, so we're getting 8.94 or 9398, right? For data that is on the data set, so if we put 1, we almost get there, but we don't get it completely right. You see, for 1 we get 1, for 2 we get 3.02, we almost get 5 for 3, and for 4 we should get 7, we get 6.96. We could train for more epochs, and we're gonna do right now. So let's just put here, let's just leave it going up to 5,000 epochs. So we got an error there. Yeah, that image doesn't exist. All right, so we're training here for many epochs. Let's just put this in here. So we're training, we're up to epoch 1000, and we're gonna pass the threshold where we were before. I just wanna make a point here. So we have the opportunity to train this model. It's like a really simple model, but we only have 4 data samples on that line, and they're really close together. If we were to take points from outside of the model maybe and put it into the data set, so into the initial synthetic data that we generated, maybe we could train for less epochs and get a better result, right? So this means getting more data from out there and putting it in your data set, in your training set. That way you would be training a model a lot easier. It seems like it's converging, so we have like an almost next to 0 loss, and we're up to epoch 3,900. So we could probably stop there, but we're gonna let it go in so it converges up to a bit closer. This is a linear regressor that we were trying to set up. This is the example that we've been doing. We're not gonna cover glitch. I thought we were going to be able to, but I think it was better just to see this in plain JavaScript. All right. And right now, well, this finishes, it's gonna finish now, but I'm just gonna take a quick water break and then we'll wrap it up. All right, we're back. So let me just take a look. All right, I'm here. Okay, so we were wrapping up. So we've mainly seen this today. So this seems to be something that we've covered. We didn't really get to cover this part here, and we'll probably leave everything else below here for some other time. So maybe live 12. And we're gonna put this to be orange. Maybe it's purple. Okay. All right, so let's go back. We have our model. So, the model right now is on the tab. So it's been trained there and it lives there. If I refresh, we lose the model so far. So we haven't seen how to even save this model at all. So, but the nice thing we can do now is that we can predict. So we can predict that for number 4, is 6.99993. We're not getting exactly there, but almost there. If we look at our input data initially, we can actually make a helper function for this. I think, let me just see how to just get the format of this. Shape, strides. Where is the data of this tensor? Tensor 2D, model predict, shape, strides, 1. So if I let me just see. So if I print this object, I get 6.99, right? But if I just call model predict, I'm getting a variable, and I'm not sure where. So let me just see. So we could do let prediction equals, well, let's just do the let prediction equals this. So I have my prediction. I can do prediction print. Can I do prediction? Can I do prediction 0? I'm not sure. Okay, so let's see, where can we get? Yeah, the print method works, but I actually just want to get to the information themselves. So the shape, print d type, print a array. All right, then array. Okay, so we can actually do here my prediction array, and then we have a promise. So we can do, can we do this? Oh, wait, right. So we're getting somewhere now. Okay, so we're getting the number. So this is what I wanted to get to. So with this method, we can get the value, so the actual float value of the prediction that we're doing with our model. What I want to do is I want to build a helper function that from this prediction, we actually get this number, right? So we're going to do some function that is going to be predict, and the function is going to take a input data, so that's going to be a tensor, and what it's going to do is that it's going to do model predict with the tensor. Well, actually, because the tensor is always the same shape, I'm going to get the value. So input, and our input is going to be in here, and we're gonna get always the 1x1 shape, and then we're going to return weight prediction array 0 0. All right, so let's see if this works. We're missing bracket here. Okay, constant prediction. Model.predict TF tensor to the input. All right, is there anything wrong here? So let's try to start from scratch. So if I just return a and define, all right, that's good. Oh, I'm really tired. So let's get back here. So if I do predict with 2 T's. Predict, it's gonna be input, and we're gonna return the input. All right, so I can do predict for negative 4. All right, so we're gonna redefine this, and we're going to now paste the code that we have here. To paste here, and we're gonna return, so return pred. All right, okay, 1 second. All right, let's keep going. All right, and now we're going to see if we can put here the value is going to be a weight prediction array. Let's see if this works. Weight is only valid in async function. All right. So maybe we need to do this, then we return our let's see how they do it here. Array all right, let's see. So what if we now do predict 4? Maybe that's not waiting. Okay. Yeah, I'm not sure what's going on, but I just wanted to make a helper function to make sure we can get values a bit easier. But I don't want to spend a lot of time right now doing this, because it seems like there's something that I'm not getting right. So we can try it some other time. Okay, so let's get back to where we were. So we can get a prediction, and then we can get the value with this code here. right? So maybe what we can do is just say await model.predict TF tensor to D 4, 1, and 1, and then array, and then we do 0, 0. Does that work? Yes. Okay, so just with one line we can, let's add this to the code. Get an output. All right, and maybe just to try it, if this works, prediction. So let's say async what is an unknown identifier? Model.predict. I'm not sure. Not sure what's going on right now, but okay, well, at least we'll just do that. So we'll just use that code to predict. So we can change here. So for 1, we're getting 1. For 2, we're getting 3. For 3, we're getting almost 5. For 4, we're getting almost 7. And for 5, that is something that is on a data set, on our training set, but we needed to get 9, we're getting almost 9, right? So it works. I mean, we could go and say now, okay, what is the value for 600, right? And the value is 1,198. That is probably 1,200, right? What is going on is that the model just so 1.6. What is the linear function here? So it's x is, all right, let's wrap it up here. So this is what I wanted to show today. The one thing that we didn't see that I think it's cool is this method. So this method is a TensorFlow load graph model that you can see on TensorFlow Hub. So let's put here a link for next time. So the link is going to be for TensorFlow Hub models in TensorFlow.js. ResNet30, no, 50, I think. ResNet50. And then the actual code is here. All right, so what happens with this, right? In our code, we're loading a model that trains here, and we are manually defining the model. So we can remove this thing from here, but we're going to leave it. So we have a model that we're defining, and it's a sequential model. It's just a linear model that we're training. The one thing I wanted to see is that if we converge by, we can get now, say, okay, for 600 is 1,200, and I don't know, maybe for this number, it's that, and I don't know if that should be 70,000. So I'm not gonna really add it. Yeah, I don't really know about this one either, but let's maybe get, I don't know, something like 50. Okay, so that should be 99 or 100? Probably 99. All right, so yeah, I don't really know if we can do this way, but let's just put, okay, so that's clearly 23. So for 12 we can put 23. For maybe minus 10 is minus 21. All right, so we converged here, and let me actually remove those. Right, so if I remove these ones and save, I'm going to leave them there. I'm going to reload, and we're just going to see here at Epoch, maybe Epoch 200, we're at 0.04 and 8.63, right? If I now save with these new numbers, so we added 2 more samples to our data set. Let's see where we are at Epoch 200. And yeah, so this probably we need to make this 6x1 tensor. All right, so we just added 2 more samples, right? We have 4, so it's 150, so it's like 50% more. And at Epoch 200 we are at 902, loss is 0.0007. So if we compare these two, by just adding 2 more samples of data, we went to a prediction that is a lot closer to 9, and the loss is 64 times smaller, right? Yeah, 64 times smaller. So once we do this, and we're training here for 5,000 epochs again, I don't really think we need to get to 5,000 epochs anymore. So we can actually stop that. Let's go just to 300 epochs. So I'm reloading. We're going to go to 300 epochs, and then we're going to get our code to predict. So let's see if we predict for number 5. You see we're getting 9.000. It's a lot more accurate. Let's see, we can now guess the number for 600. It seems, yeah, I don't really know what's going on in there. Let's run this same code here. It's still loading. Okay, for 2 we get 3. All right, yeah, so by adding 2 more samples we increase or reduce the loss. The loss decreases faster. Okay, and the thing that I want to see, that I promised before, is this code. So if we add here, so let's say we define our ResNet model and we just do this. So we just we're just loading TF load graph model. We're putting 2 parameters. One is the URL, and then the other parameter is like from TF Hub true, right? Let's see what happens. So we're gonna open, so we're gonna remove the training code here. I just said the training code. It is not the train code. All right, so we do that, and if we go to sources, no, to network, we can see here, I'm gonna just zoom out. Yeah, we can see there, we're loading all these shards of data. There's like 25 .beam files that are the data of the model. So we're downloading a model.json that has the ResNet50 information, and then all these data here are binary files that contain the weights of the model that we're trying to get. I don't know if they have, this model has automatically been converted with TF.js converter. And let's see if we can print a model summary. So if we could do ResNet after we've loaded the model, if we could do ResNet.summary. That's something that exists on TensorFlow. Not sure how it works on TensorFlow.js. ResNet summary is not a function. All right. Okay. So we can do here, we could do something. Well, first we're going to comment out that image. So we can do ResNet dot layers, for instance, undefined. ResNet is a promise. Load graph model. Okay, this graph model is like 100 megabytes. I don't know how long it takes. TensorFlow Hub sample with TensorFlow.js model. So the code that I'm trying to get to is this one here. So load graph model. Okay, TF load graph model. Okay. So we can predict and print await. All right. We also need to await. So here I'm adding the await statement, and because that seems to be a promise, we're going to close this one. Await is only valid in a sync function. Why is this not letting me? Example, loading MobileNet from a URL and making a prediction. Model await. This is what it should be. Where is anything function? Load graph model. Not sure what's going on. Oh, I see. Okay, so async test. So we gotta get the function execution out from the main thread, right? Async anonymous async function. Let's take a look. How are we holding there? We're almost done. Async function X. Maybe. All right, so that's getting executed, and we'll just make sure here, hey, So if this took some time, this is 1 and this is 2. Right now it's 2, 1, but if we put this code inside of here and we wait for it, so 1 runs and then the model is being loaded and then this returns. So this is ResNet50 was loaded. Or maybe we can do this loading ResNet. And then we can say here done. All right, so now we're talking, right? So we're defining this inside here. So we're not defining it for the overall function, but we could do this. We could do let ResNet, and then we could do that. Right, so now we have ResNet here, and I'm not sure we can do that, but we can surely do this. Nope. All right, let's forget about this. Okay, so we have ResNet here. Let's see what we have. So we can console log ResNet when we load it. All right, so we have the model, we have executors, artifacts, load URL. So let's try to do a prediction. ResNet predict, and we're gonna need to take a look at the input data format to be able to pass an image through there. Oh, okay. So on the TensorFlow API, we saw load graph model. Yeah, we saw this thing here. So we can, I assume the shape of the input is the same than this one. So we defined our input. So this is just like a tensor with the shape of the input shape that we need to pass through. We do this, we pass those zeros into our model. So we put here done, and now we can put here predicting, and maybe just delete that one. All right, let's see. Will this work? Predicting, done. All right, so that's an image that we have classified or like passed through ResNet, and I'm not sure now. So we're getting that image. Those are the predictions, right? So let's see if we can do the same thing that we did before, where we do a, oh, maybe the function we were doing before needs to have a wait. So async, that's why we couldn't do it before. All right, so let's see. Right, so this thing here is a promise. So we can actually do a wait there and do, this is our output, and we're gonna do here log output shape. All right, so what we're doing at the moment is seeing the shape. So we have, it's just one-dimensional list of labels, and we could here go and just print that. So print those values. Oh, no, we can't. Let me just print that. Okay. All right. Oh, okay. We need to get the array first. Sorry again. The method, yeah, so that's it. Okay, yeah, so this is something I haven't done before this way. Well, I have, but not exactly at this level. So what we have here is a set of probabilities. I don't know if this is probabilities or logits. Probably logits. So we will have to see how to maybe get a softmax function here, but let's get the argmax, TF argmax. Let's try it. Argmax axis 0. Okay. Yes, we're getting a tensor. Let me just see. TensorFlow.js, ResNet, argmax, predict. That's TensorFlow core. We get back at the same place. ResNet, predict, argmax, classes. Get ktope classes, logits. All right, so we're actually getting logits. So get top k classes. Where is that function? Oh, we define it here. ImageNet classes. Where are we getting the ImageNet classes? Data. All right, values. Okay, so I'm gonna stop now, but I'm gonna do a recap of what's going on and what we can see next. So the get ktop classes is a function that, you know, as I mentioned before, the data we're getting back from ResNet, I believe, is logits. It's data that doesn't represent probabilities, but a different measure that we need to convert into probabilities, right? Or at least need to evaluate in a different way. What we can do is that we can sort those as we're doing here, so processing them and then getting the 5 top or 510 classes or something, and then grabbing the IDs of those classes, and on the ImageNet list of classes we get the corresponding names of the categories that have been classified. So what I'm going to do is put a note to myself for next week here. Process logits to ktop classes, and we'll see here sample with MobileNet. And what we also want to do is in some way display ImageNet class names. That I think that's what this network is straight width. All right, so we're gonna wrap up here. So we're gonna finish now, and I hope this was useful. So we're gonna go to the repo. Before we end, we're going to open the folder, and we're gonna make sure that we put here live number 11, and that we move our website code into here. So we did this, and we did that, and for all of this, I'm going to edit the file to make sure that so we have two different files. So this is going to be ResNet HTML TensorFlow.js ResNet and TensorFlow.js I think it's linear regressor. So the linear regressor one, we're going to leave what we had before. So we're going to remove some of the code that we had here that we don't need. We're going to uncomment all of these things. This is a good practice to, before I go upload all the code to GitHub so you can take a look. Yeah, and I think what was going on here is that we also need to do this. We also need to do async and run this function this way. This is what I'm going to put on the other file. So only this part, not only this part. Yeah, that part. All right. Okay, cool. So in this one here, so we're going to remove this code, but yeah, we're going to try to run this here. So we have that, so we do async. So we are fitting, so and maybe we can put this at the end, right? Yeah, this would make sense on batch end, but let's just leave this here. Let's just make sure that this is true, that this works. Right, undefined. What is that undefined? The output. All right. All right, so this example is now working. Okay, so we can push that one. So and what about the other one? So what we said is that we can open this one. All right, so maybe right. Let's see. So this one is training right now for 300 epochs with the augmented data set that we put there. And we're just going to verify that this works. So, and then this is the input number that we want. So we can have 5 here. And yep, so we run this and that works. Okay, cool. And this is our image. So right. So add live 11 TensorFlow.js files. And we're pushing. All right, I will take this moment to say thank you to everyone who connected today. If you're still watching, leave a comment to know that you've enjoyed or what you enjoyed and what you would like to see more of. We've seen a first approximation of how to get TensorFlow.js and run it on a web browser from scratch to build a model with TensorFlow. So we've been writing a model in TensorFlow on the browser. And we've also used TensorFlow Hub to download a model directly from there, specifically ResNet50 version 2, which is a model that if we formatted an image or got an image from the webcam and pass it through the model, we'll get a prediction. And from that prediction, if we go into the ImageNet class list, we can get the index of the maximum confidence predictions and then get the names of those classes. So we could know what the model is telling us that the image that we're classifying is. So this is the end of today. Again, just gonna write a note there for me. We can use images from the web or from the webcam as model input and classify on demand. That would be a good exercise for next week. So I'm gonna highlight this. I think this is a really good intention for next week. And yeah, let's see. So next week, this is the 17th, and next week is going to be that's like Christmas Eve. So I don't think I will be doing a live stream, at least not in the afternoon or at night. I might record something another day and put it there live, or I might just do a live stream earlier in the morning, so earlier in the day. just to let you know, because I will hopefully be with my family that day if the situation allows for it. All right. Yeah, Sujay and Pedro, thanks to you for being there. I think, yeah, this was a pretty technical stream, but these are core skills that we need to start building right now if we want to be able to build up and get to use more of TensorFlow.js on the web, on desktop applications, and on our websites. I will, I have the intention to build some of the demos that we're working on today into my website so they can be accessed online. But for now, you can go into the browser, and if we go into the repository, you can go here, and then you can visualize the code. And if you just download these files, you can run it on your own browser. And because they're downloading TensorFlow.js from the TensorFlow, well, from the CDN, they will run in your machine, and you don't have to set up anything locally. That's the good thing of TensorFlow.js, that everything runs on the browser and there's no need to set up anything. Closing there. This is now the trash. And yeah, I will definitely let you know when I'm recording. Let me see where we have the outro for whoever is going to be watching in the future. Hope not that one. Okay, and yeah, thank you guys. If you have any other ideas for what you would like to see over the next weeks on the channel, just go into the Discord channel, join us, and let me know. I will be, I will be taking them into account. Let me see if this thing works. Yeah, thank you again. This was part of one more live stream on the machine learning series. Go ahead and like this video if you'd like to keep seeing content like this one, and subscribe if you're not subscribed yet to see future videos and when I go live next. Again, you can join us on the Discord community or Discord server at nonodomas/Discord. And yeah, so that was Nono Martinez Alonso, and I would like to thank you so much for watching, and we'll see you next time. Bye. Yeah, and Merry Christmas and Happy Holidays, and I would probably see you next week. Hopefully we can do something. And yeah, thank you, Pedro. Thank you, Sujay. And thanks to everyone who is watching. Bye. And don't forget to leave some comments. I would love to know what you think about this video